Hello everyone. This is likely the final overview video for Auggie before we start getting into more of the meat of the program. So I'd like to introduce you to one of the final elements that make it possible to run Auggie as a design studio. And remember that the overall goal here is to use the Pokies motion screen that I'm developing here as a design tool to design an actual machine. And at that point you would redesign the screen, either use the current screen and remove all the things that are used for design elements, or create a new machine that matches the definition of the machine you're creating. You may not, for example, want G-code displays or script displays or anything else on your end user's screen, perhaps not even a toolpath display. But this screen overall is meant to allow you to design. Now, obviously, we're going to be doing that with scripts, and the only scripter that you've been introduced to so far is the scripter built in for debugging the screens and its library. And that scripter's library only holds design elements for the screens and what they do on scripts. But that's only important really for the final stage where you're actually designing your user's screen. In preliminary stages, you're going to be more interested in functional scripts that affect motion and how you deal with those. And that's done with this new button up here called Lib. And this is our new library. This is the part of Auggie which will be growing the most over time. It will probably eventually morph into a tree with tags added to each library as to the type of library. Is it decorative? Is it logical? Is it functional? Is it mathematics? In the meantime, you're encouraged to name any libraries you create with words that describe them. The next library which you'll see here appear from me is the G-code library, and it will avail itself of scripts from all the other libraries that get written in order to add G-code commands or to deal with M-codes and G-codes that are in the stream of the program that you're running. You can see here I have 3 libraries put into the system so far. We have check marks beside each of them. If you uncheck a library, it turns it off. This allows for overloading. You could have 3 libraries that do the same thing with different devices or in different ways, and you check the library that is the one that you want to use. So you could duplicate these function names in another library, provided you only check the box for one library. When you check a library, it will list you the functions that are in that library. This, for example, is our free access library, and it deals with setting feed rates, rapids, rapid moves, feed rate moves, setting the speed, and so on of the free axes, which I'll explain in a moment because you haven't yet seen free axes. Then we have a motion I/O library, which at the moment only has 4 calls in it, and this is used to get and set relays on the PO keys that's used for motion or output control signals, and this will grow as I add more for PWM and the various sensors that are on a PO keys. So if you had a PO keys connected for motion, you would check the box saying I have motion I/O, and you would use it. Another one will appear for an I/O for a secondary PO key, so that you can use libraries that are dedicated to it. We also have a library of system callbacks. These are scripts which call back to you when things happen in the system. When the system resets and loads all the scripts, when it's finished, it will call this script. So these scripts are here for you to modify to do what you want. At the moment, they only have in them a print statement, as I'll show you in a moment. You can create new libraries by hitting Create New Library. If you do that, you'll be asked for the single word name of a library, which should be something that can be used as a folder name or a file name, because it actually creates a folder with a file in it, which is the library. All libraries are a single file. If you need more than one file for a library, you would be encouraged to create more than one library. Again, when you check it, it turns it on. When you uncheck it, it turns it off. And I'll show you one of these libraries, system callbacks for example. We can at any time hit the local edit button. And if we do, it will appear down here on the script window so that you can edit it. Or if you have the scripter open and turned on, you can hit the live button and check out a library into this by saying local edit. So here I have 2 libraries checked out. One is checked out inside the scripter and the other one is checked out inside the screen MDI. Now, when you go to the library and check in, it will look to the first line of the library to determine what the library name is. And if you're in the powered up in the scripter, it will take this one. If this scripter is shut down, it will take it out of the script MDI. But it'll always check the names and so on to make sure that things are good. Okay, so let's take a quick look at that original script that I checked out, which is the system callback library. You can see here we give it a name, system callbacks. This is all done automatically for you. When you create a library, it gives you a template. But you can see that each one of these functions simply prints a word: system disabled, system enabled, and so on. I'll tend to hook things with a print statement just so that you know exactly what's happening. But these scripts are meant for the user to modify. If you want the system to do something when the user e-stops, this routine will always be called when the system goes into e-stop. When a user presses e-stop to enable the system, you'll always get a call back. So these callbacks are useful when the user presses run. You could check safety conditions which are pertinent only to your machine, and then deny the run or allow it depending on what you want to do. Anyone familiar with C programming would be familiar with callback functions from a DLL, and these are very similar. And a lot more will be added over time so that a machine designer has access to pretty much every event that we can think of as it goes. Alright, so the last thing that I want to talk about is the free axes. If you have a 57 CNC, you have 8 axes, and you may have been wondering what the intent was with those 4 axes. They've been added as a secondary system. You can see up here there is another panel, and this is a different type of panel. This is a panel, the diagnostics panel, as you can see nothing on it, and this is because it's defined as shrinkable in its properties. This panel is simply defined as a regular panel. So if I click the display button, it will zoom out and stay zoomed out while I do other things. And if I shrink it away, it shrinks away so that you can still see it. Now, obviously the numbers are ridiculously small, but I look at them more as twinkle indicators to show me that work is being done. If I need them bigger than on my user's screen, I would make them larger and more prominent. At the moment, you can see one of them's going, and that's because I've defined free axis number 5. The first free axis is axis number 5, and then we have 6, 7, and 8, of course. And I have defined number 5 as a speed source axis, which means that I can send it a command to set its speed. And you can do that in a scripter because it's in the script library. And if you didn't know what the command was to set something like that, we've just hit the live button, go to free axis, and under free axis you can see here we have one free set speed. And it even tells you how to do it. Put the axis number and then the position or speed. So let's go back to our screen thing here and say free set speed axis 5, 1. And if we hit run, you can see the axis has come to a stop. It's not really stopped, but at 1 millimeter per minute, it could take a while to do much. So let me just speed it up a little bit. Here I've got it set to a speed of 22. So this will be 20 in steps per second. This would be 22 times whatever the steps per second is for the unit. These displays follow the same settings that are selected up here between machine, work, and steps. And you can enter a number into them to zero them. For example, these ones here, I could just enter 0 and 0 the display just like any other DRO. So these 4 axes work totally independently of running programs, and because of that I call the Cartesian ones orientation axes, and the ones that you set as speed are conveyor belts or spindles or anything else along the line. I can't tell what you're going to use those for, so really they have no name or defined function. They're being set up as a separate Cartesian system that can run in parallel with the original one. So while you're running G-code, you could trigger a script that tells these 3 stepper motors to move to a tool changer position, grab a tool, and maybe this final one flips a lever or something, who knows. But they are a parallel system. Parallel scripts are also being introduced where you can specify that a script runs in linear time, like a G-code command does, or that it runs in parallel. So once the script starts, the G-code continues, and so too does the script. So you could have multiple parallel scripts stacked up, each monitoring a part of your system, one adjusting the spindle based on the temperature of the spindle, or one adjusting laser power based on an infrared camera's output, whatever. So these are some of the changes that have occurred. You'll see the library appear with its new library readings soon. I'm just working out a final few bugs before I make a release. And then we'll start into the meat of how to program Auggie, because this really is my final envisioned screen for designing a system. So that's it for this video. This version that I used for this video isn't online yet. It'll be online within a few days.